Hi students, in this video we are going to look at practice problems for trigonometric integrals and trigonometric substitution. So this is going to be our last video clip for this chapter. So let's start by looking at example 170. So we have integral of 10 to the 5th power multiply secant to the 7th power. All right, so we are going to start by trying our technique from the lecture. So I told you that when we see secant and tangent multiply together, so we're going to try substitution u equal to 10, u equal to sec. Well, if both methods do not work, we are going to try to adjust by using identity and trying to change everything to secant, and then maybe we have to use integrate by parts. So let's start by trying to pick u equal to tangent. What if I pick u equal to tangent? So I'm gonna get 10 to the 5th power secant to the 2nd power, 7th power, and then I pick u to be my tangent. Well, in that case, I am going to have secant square here, and then I can cancel two factors of secant, so I get secant to the 5th power. You can see that this will not help because we're gonna have d10 and 10 to the 5th power. This is good, but we still have secant to the 5th power, which we cannot convert to tangent because this is secant to the odd power. So that means choosing u equal to tan theta does not work. So we're gonna try another way. So why don't we let u equal to secant and see what happens. So if I pick u equal to secant, my du gonna be secant tangent d theta. Well, if you try to simplify the integral, so you're gonna get integrate. Let's say 10 to the 5th power, and then secant to the 7th power, and then, well, I switch d theta to du over secant and tangent. Well, it looks good at first because, well, you can see that you can cancel one secant and then you can cancel one tangent, and all you have left, these are all even power. Well, we have a chance to complete this question. So let's keep doing it. So, well, I'm gonna change secant to u. So I have u to the 6th power and then du. All right, so for 10 to the 4th power, well, I need to convert this thing to u. How? So we have cosine square theta plus sine square theta equal to 1. And then if I divided everything by cosine, so I have 1 plus tan square equal to secant. Well, that means just tangent square. This is secant square minus 1. So from here, I am going to say that this is integral tan square, everything square times u to the 6th du. And then that tan square theta, so I can switch it to secant square theta minus 1 square, and then u to the 6th du. Well, actually, this is u square minus 1, right? Square u to the 6th du. Well, I can expand u square minus 1 square, so I get u to the 4th power minus 2u square plus 1. And then this multiply u to the 6th du. Well, everything looks nice and clean now, so we can integrate easily. So we're gonna have integrate u to the 10 power minus 2 times u to the 8th power and then plus u to the 6th power du. All right, so I integrate this thing, so I have u to the 11 over 11 and then minus 2 times u to the 9 over 9 and then plus u to the 7 over 7 plus c. Well, the last step is to convert back into the function of theta. So that means I have the answer to be secant to the 11 theta over 11 minus 2 over 9 secant to the 9 power, and then plus secant to the 7 power theta over 7 plus c. All right, that's for this example. So next one. So example 171, you can see that this is the question asked you about trigonometric integrals again. Well, we have sine cube and something inside parentheses, square root x, and then over square root x. Well, of course, we know how to integrate sine cube. However, inside parentheses, we have square root x, so maybe you need to do a substitution first. So we are going to do a basic substitution here. So I'm gonna let y to be square root x. Just keep it, just go straight forward. So we let y equal to square root x, and we hope that our integral gonna convert to something that we can use integration technique. So once I let y equal to square root x, I have dy equal to 1 over 2 square root x dx. Well, this is just a basic substitution. Well, I'm going to convert this thing to integrate sine cube of y over square root x, and I can switch the x to 2 square root x dy, right? Because from here I have dx equal to 2 square root x dy. Well, this is perfect because you can cancel 1 square root x, and then you're going to have 2 times integrate sine cube y dy. Well, this is pretty easy, right? Because we already did this one in class, I guess. So for integrate sine cube y dy, so we're going to let u to be sine or cosine, and that should be easy to integrate, right? So from here, so I'm gonna try let u equal to, well, I'm gonna go a little bit faster for this question. So let's keep it going, and I am going to pick u inside the question. So we have to time integrate sine cube y dy, right? So I'm gonna switch dy. Let's say I'm gonna switch dy to d sine y. Well, I just pick u equal to sine first and see if it works. If not, I'm gonna switch to cosine. So if I pick u equal to sine, so I have cosine y here, right? Because differentiate sine, you get cosine, and then you can see that you cannot cancel this and this that I circle in green because, well, it does not match. So we are going to switch our approach. So we're gonna pick u equal to cosine. That's better. So if I pick u equal to cosine, so I get negative sine y here. And that looks pretty good because you can cancel one factor of sine. So on the next step, I am going to have 2 times integrate sine square y d cosine y. Well, negative sine as well on the, in front. And then now I can use the trigonometric identities to switch sine square y to 1 minus cosine square y d cosine y, which is good now, right? So now I can integrate. So integrate 1 d cosine y, so I get cosine y, right? And then integrate cosine square y d cosine y, so I get cosine y cube over 3. Does it make sense? Well, I can will cosine y to be my, my u, and then it's similar to the situation that I integrate u squared u, so I should get u cube over 3, right? And then at the end, I just plus c. All right, if I multiply negative 2 inside the parentheses, my answer is going to be negative 2 times cosine y, and then plus 2 over 3 cosine cube y plus c. Well, do not forget that you already did a substitution on the first step. So my answer must be in terms of x. So I'm going to have negative 2 times cosine square root x plus 2 over 3 cosine cube square root x plus c. All right, and that is final answer. Looks good, right? All right, we're gonna move to next example, example 172. So still sine and cosine integrals. So here we have integral of sine square times cosine square. Well, you can see that when you have the product of sine and cosine on the integrand, I told you that you have three ways to deal with it. So maybe you pick u equal to sine, u equal to cosine, or you can just use identity. So for this question, you can see that if I pick u equal to sine x, well, what happened is I have cosine x here on the denominator, and then one factor of cosine gonna cancel. However, I'm gonna get stuck because, well, I have the cosine here, and I cannot switch cosine to sine. That means I cannot integrate this thing. The same thing with the situation that I pick u equal to cosine. So I'm gonna cancel out one factor of sine. And then at the end, I'm going to have the same problem because I cannot switch sine to cosine. So that means the first two methods do not work. So you need to use identity. Well, you can memorize that when you see the even power of sine and cosine. Well, picking u to be cosine or sine, it will not work. You have to use identity. So for this question, we're going to use the identity that sine square x equal to, let's say, this is hard to memorize, but you have to. Let's say I cannot remember as well, so it's going to take me a while to memorize this thing. However, our instructor, we just talk to each other and we think that it is possible that we're going to give you a formula on the exam. I will keep you post on that update. So sine square x, this is equal to 1 minus cosine 2x over 2. And then cosine square x, this is 1 plus cosine 2x over 2. All right, we are going to integrate first. So sine square x and cosine square x dx. We are going to find the final answer for indefinite integral first, and then we're going to plug in the upper bound, lower bound at the end. So we're going to have integrate 1 minus cosine 2x over 2, right? And then here we're going to have 1 plus cosine 2x over 2 dx. And then I can pull out a quarter, and then on the integrand, so I can multiply back. So I'm gonna have, well, keep in mind this is a minus b times a plus b. So actually I should get the yellow thing square minus the orange square, right? And that will be a quarter integrate 1 minus, so cosine square 2x, so this is still square of cosine, so you need to use identity one more time, and this is going to give you 1 plus cosine 4x over 2 by using identity one more time, and then dx, right? And then now let's simplify a little bit before going further. So we're going to have a quarter times 1 minus 1 half minus cosine 4x over 2. Sounds good? Dx. And then now I have a quarter time integrate 1 half minus cosine 4x over 2 dx. Well, better than that, I can pull out 1 half, so I get 1 over 8 integrate 1 minus cosine 4x dx. Cosine 4x dx. All right, now I can integrate. So I'm going to get 1 over 8 x. And then to integrate cosine 4x, so I get 1 over 4 sine 4x. Right? Because differentiate sine, you get cosine. So when you integrate cosine, you get back sine. Well, you need to have 1 over 4 here because this is cosine 4x. and then plus c. All right, this is going to be your indefinite integrals. And then when you answer the final answer, it's going to be integrate sine square x cosine x dx from 0 to pi over 2. Then you plug in. So you're going to plug in 1 over 8, and then you plug in x minus sine 4x over 4 here to be the number where x start from 0 and it's go to pi over 2. So that means you get 1 over 8 pi over 2 minus sine 2 pi over 4. That's the first one. And then minus, well, on the second term here, so you get 0. Because when you plug in x equal to 0, so sine 0 going to be 0. And then that second term going to go to 0 anyway. But you also know that sine 2 theta, this is going to be just 0. So that means your final answer here going to be just pi over 16. Sounds good? Well, keep in mind that this is the standard technique that you should do when you face the product of sine and cosine with even power. You have to use identity. So there is no other way that you can solve this one without identity. Sounds good? All right, next we are going to look at example 173. So for example 173, you can see that here we have 64 minus x squared under square root sine. So we are going to use the trigonometric substitution, right? Because this leads us to something that we can do a trig sub for sure. All right, so because the form that we have is 64 minus x squared, so this is the same thing with 8 squared minus x squared. Well, this suggests us to choose when you have a square minus x square, so you're gonna choose x equal to a times sine theta, right? So now our integrate square root 64 minus x squared dx. So this is going to be integrate square root 64 minus. So I am going to replace x by 64. X by 8 sine x. So x squared gonna be 64 sine square theta. And then I have to change the x to d theta. So when x equal to 8 times sine theta, the x is gonna be 8 times cosine theta d theta. All right, so I'm gonna just add that thing at the end. All right, now we can just simplify it. So we're gonna pull out 64 here. Then we have 1 minus sine square here, and then 8 outside, and then cosine theta d theta. All right, so you can see that what you have here is you have 1 minus sine square. So that 1 minus sine square, this is going to be the one that you can use the identity to be cosine. So it's going to be 8 integrate. So take square root of 64, you have 8. And then square root of 1 minus sine square, you get square root cosine square here. Well, let's keep it like that first. Well, now you want to take the square root of cosine, so you're gonna get absolute value. However, because here you pick x equal to 8 times sine theta, where theta is in between negative pi over 2 to pi over 2. So that means your cosine gonna be positive. So that means the term here, this is going to be just cosine theta. Well, that means your integral going to be 64. So I just group up the constant, integrate cosine square theta d theta, right? Because you just have cosine 2 times. This is the first cosine and this is the second cosine. All right, now we have 64, well, I have to use identity here, so I'm gonna get 1 plus cosine 2 theta over 2 d theta. So that's mean I get 32 integrate 1 plus cosine 2 theta d theta. Well, if I integrate this thing, so I'm gonna get 32 theta plus integrate cosine, so I get sine 2 theta over 2, and then plus c. All right, we almost uh, obtain the answer. So we're gonna simplify a little bit more. So 32 theta plus 16 sine 2 theta plus c. All right, now we need to convert theta and sine 2 theta back to x. So because our uh, x is 8 times sine theta, so that means sine theta equal to x over 8. So if you fix 1 theta here, so that means the opposite side going to be x and the hypotenuse side is going to be 8. So that means the adjacent side going to be 64 minus x squared, right? And then because you pick sine theta equal to x over 8, that means just theta, this is going to be arc sine x over 8. So the answer here gonna be 32 times arc sine x over 8. That's the first term. And plus 16. Well, sine 2 theta, this is, well, sine 2 theta, this is going to be 2 times sine theta cosine theta. This is a double angle formula for trigonometric function. And then I have 32 times arc sine x over 8 plus 32 times sine theta and cosine theta, which sine theta is x over 8, right? And cosine theta is going to be square root 64 minus x squared over 8 plus c. All right, you can cancel out something. So that number 8 that I highlight in green, so it's going to cancel out with 32. So you can say this is just 4, right? And then 4 gonna cancel out with 8, so I have 2. Well, I can keep this thing pretty simple to be x times square root 64 minus x over 2. All right, that is our answer for this question. Sounds good. All right, we're gonna move to the next one, buddy. Example 174. This is the one that we need to integrate square root and 1 over square root x squared plus 16. Well, we're going to integrate to find indefinite integral first, of course, and then after that we're going to plug in 0 and 1 at the end. All right, let's do it. So we're going to start by observe that we have x squared plus 4 squared here. So that means we have to pick x equal to 4 times tan theta, right? Well, if you want to make sure, you can say, yeah, your tan theta is going to be between negative pi over 2 to pi over 2. Well, this is our pick. Well, when you pick x equal to 4 times tan theta, well, you can save your time by just, you can say this is going to be dx equal to 4 secant square theta d theta, because you have to use dx anyway in your work somehow. All right, so the next step, we are going to start the problem. So integrate 1 over square root x squared plus 16 dx. So this is going to be integrate 1 over square root, let me see. So we're going to replace x squared, x by 4 tan theta, and then we square it, and then plus 16, and then dx is going to be 4 times sec squared d theta. All right, so if I simplify the thing under square root side here, so I'm going to get integrate 4 sec squared theta over, all right, so I'm gonna square that, so I get 16 tan square, right, and then I pull out 16, I have square root 16 tan square theta plus 1. All right, and because we know that tan square plus 1, this is equal to sec square theta, right? So we're gonna have integrate, so 4 times sec square theta. So on the denominator, I have 4 times absolute sec theta. But because, well, we pick theta in quadrant 1 or quadrant 4, so sec gonna be positive. And then now I can cancel out 1 sec. So here I have integrate just sec theta d theta. This is going to be our reduced form of the integral. So now we're gonna integrate sec. So we're gonna have log absolute sec theta plus tan theta, right? Plus c. All right. Well, the next step after you get log absolute sec theta plus tan theta plus c. So now you need to convert back to x. So again, because you know that x equal to 4 times tan theta, so that means tan theta equal to x over 4. Well, this is going to be your picture. Tan theta equal to x over 4. Well, your hypotenuse gonna be x squared plus 16. All right, and that's mean when you plug in back here, so you're gonna get log absolute. So sec theta is gonna be square root x squared plus 16 over adjacent, which is 4, and then plus x over 4 plus c. All right, so that means when you integrate from 0 to 1, dx over x squared plus 16, well, this is going to be log of absolute square root 1 squared plus 16 over 4 plus 1 over 4 absolute minus log absolute square root 0 squared plus 16 over 4 plus 0 over 4. Well, if you compute this thing, it's going to be log of square root 17 plus 1 over 4 minus log 1, which log 1 is equal to 0. So that means your final answer is going to be log square root 17 plus 1 over 4. Well, this is going to be your final answer. All right, sounds good. So the last question for this series, so it's going to be example 175. So this is still trigonometric substitution. So let's see how it works. For this question, this is an interesting question. So we are going to do a trigonometric substitution. So when you see 9x squared minus 1, here this is actually 3x squared minus 1 squared. So our suggestion for substitution is going to be, this suggests us to pick 3x equal to 1 time sec theta, right? Well, actually, it means x equal to 1/3 times sec theta. All right, so that is going to be our substitution here. So once you pick x like that, so the x gonna be 1/3 times sec theta tan theta d theta. All right, so now we are going to integrate this thing. We'll start from integrate 1 over, so your x squared here gonna be, you just plug in, that's going to be 1 over 9 sec squared. Well, this is x squared, and then your square root, so 9x squared is going to be 9 times 1 over 9 sec squared theta. All right, and then minus 1, and then dx is going to be 1/3 times sec theta tan theta d theta. All right, it looks like a big term, but well, we hope that something gonna cancel out. 9 cancel 9 here, first of all, and then, well, now you have integrate. Well, let's first cancel something. So 1 secant here, gonna cancel with 1 secant here. So we have, and also 1/3 here, gonna cancel with 1/9 here. So we have 3 on the top. Does it make sense? So that means we have 3 on the top. This is from the cancellation of 1/3 and 1/9. And we have tangent on the top. This is from tangent on the top here. This is from here. And 1/3 and 1/9 here. Gonna cancel to get 3. And also we have secant here that cancel with secant square over there, the orange one. So we have sec square, just sec theta on the denominator. All right, and also we have square root, now sec square minus 1. Interesting, right? So now we have, and d theta, sorry. And then now we have 3 integrate tan theta over sec theta square root sec square minus 1. This is tan square. Well, this is actually absolute tan. So you can see we have 3 times integrate tan theta over sec theta absolute tan theta d theta. So we almost there, but we just need to cancel out the tangent, right? Can we cancel out the tangent? So we're gonna go back to our theory and see what did we pick for the domain when we do the secant. So I'm gonna go back to our lecture, and you can see that when we pick the domain for theta, when we do a substitution, so the theta is going to be between 0 and pi over 2, or theta is going to be between pi over 2 to pi. For this, that means your theta here gonna be in quadrant number 1 or quadrant number 2. So that leaves us the problem, right? Because if you are in quadrant number 1, so your tangent gonna be positive. If you are in quadrant number 2, your tangent gonna be negative. Well, that means you have 2 cases. So we're gonna go back to this is include pi. 1 second. Well, we're gonna go back to our problem here, and then we're gonna say that this is equal to 2 cases. The case number 1, you're gonna get 3 times integrate tan theta over sec theta times tan theta d theta. This is the case if your theta is in quadrant number 1. So if it is in between 0 and pi over 2, then yes, this is going to be the case that when you take absolute value out, so you get just 10. Well, the second case, if you have theta that is in quadrant number 2, so that means, well, you're gonna have the negative side here, right? Because your absolute value is gonna give you negative side. All right, to make it clear, so I'm gonna just redo the color. So this is going to be the black one. I'm gonna copy this to the next page. All right, next page. All right, we're almost there. So we have this, and then now you can see this is actually, well, the tangent gonna cancel anyway, no matter what. So, well, here you have equal. Well, it's gonna be 3 times integrate cosine theta d theta for the first case. For the second case, it's going to be negative 3 integrate cosine theta d theta. Well, now your answer depends on theta. All right, we're almost there. Okay, good. And Now we need to integrate cosine theta. If you integrate cosine theta, for sure you're gonna get sine, right? So this is going to be 3 times sine theta for the first case, and it is going to be, well, I'm gonna do this so it just make it more easier to write. So I'm gonna move this thing, and then I'm gonna just integrate here. So we get 3 times sine theta plus c for the first case. For the second case, I'm gonna get negative 3 times sine theta plus c. All right, and that means your answer is going to be what? So your answer is going to be, well, your substitution is, well, if you go back, so you can see you let x equal to 1/3 times sec theta. So this means your 3x equal to sec theta. So that means if you mark your theta here, your cosine theta is going to be 1/3x. Cosine is adjacent 1/3x, and then this side by Pythagorean theorem, this is going to be 9x squared minus 1. All right, and then that means your sine theta are going to be what? So it's going to be, your answer going to be 3 times sine theta. That means 3 times sine theta, which is going to be square root 9x squared minus 1/3x plus c for the first case, and then it's going to be negative 3 times square root 9x squared minus 1/3x for the second case, and then this is going to be square root 9x squared minus 1/x plus c, and this is going to be negative square root 9x squared minus 1/x plus c. Now to figure out the x interval that correspond to theta is in between 0 to pi over 2 that I highlight in yellow. So you can think that you have theta is in between 0 and pi over 2, right? That means your sec theta is in between what? So sec 0 is equal to 1. So it means sec is greater than or equal to 1. So sec pi over 2 is undefined. So it's equal to infinity. So that means sec theta is bigger than 1. And that means 1/3 is less than or equal to sec theta over 3. And this is your x. So that means the first condition that you have here, this is x. This is when x is bigger than or equal to 1/3. Does it make sense? And then on the second function here, so it is going to be defined when theta is in between pi over 2 to pi, right? So this means sec theta is, well, sec pi over 2 is infinity. And what is sec pi? So sec pi is going to be -1. So this means, well, we're going to just look at one side. So that means sec pi is less than or equal to -1, which means 1/3 of sec theta is less than 1/3. So that means x less than or equal to -1/3. So the second case gonna happen when x is less than or equal to 1/3. All right. And this is going to be your answer for this question. Sounds good? All right, we're gonna end the clip here. I know I talk too fast on this clip because, well, you know, I'm in hurry to just record the clip. So if you have any question, if it is not clear, just leave the comment under the clip here. So once I see your reply, so I'm gonna answer your question under the clip here. All right, thank you all.